We now do a quick review of the first half of Chapter 5. In this first fraction, we reduce the negative 5 over 10 to give us negative 1/2. Don't write that 1 yet. We look at the x's, the negative 3, they come down to the denominator, giving us x to the 7 down below. And with that y to the minus 5th, those y's come upstairs to the numerator, and you have 1 plus the 5 that join it to give you y to the 6th. In problem number 2, we're multiplying with scientific notation. 4.3 times the 3, we multiply these numbers out in front. That gives us 12.9. And then we add these exponents there. 8 plus 17 tells us we have the 25th power. Now that can't be our answer because we're only allowed to have one digit to the left of our decimal, and so we've got to change that 12.9 into 1.29. The number out front is going to be getting smaller. We're dividing by 10, so we're going to multiply another 10 into this, and it's going to get larger, and the 25 is going to turn into a 26. When we move on to division with scientific notation, we divide those numbers in front. Now, 0.6 over 2.4, if you think of the fraction 6/24, that's equal to 1/4. And 1/4 as a decimal is 0.25. We're going to subtract exponents. Negative 15 take away 11 makes negative 26. This again is not in scientific notation, so we need to write this with one digit to the left of the decimal that's not 0. And since on the left this got larger, multiplying by 10, this is going to get smaller on the right, dividing one of those 10s off and making this a negative 27th power. In problem number 4, we have distribution. This term out front is going to distribute in and multiply by both terms inside. We begin by multiplying coefficients. Negative 5 times 8 makes negative 40. And for each variable we add exponents. For x's we have 2 plus 1 makes 3. For y's we got 3 of them times 1 more. 3 plus 1 is 4. Z's we got 1 plus 5 making z to the 6th. We now start all over again with the coefficients. Negative 5 times negative 4 makes positive 20. We add exponents for each variable. We get x to the 2nd, x to the 1st, add up to x to the 3rd. We move on to y's. Y to the 3rd, y to the 2nd adds up to y to the 5th. And for the z's we get 1 plus 3 making z to the 4th. Number 5, multiply. We see two things in both parentheses, which tells us that this is a FOIL problem. The first term of FOIL has us multiplying the 3x squared times the 2x squared, and that makes 6x to the 4th. The outer term of FOIL has us multiplying the 3x squared times the negative 7, making negative 21x squared. The inner term has us multiplying 4 times 2x squared, which gives us plus 8x squared. And the L term, the last term of FOIL, has us multiplying the positive 4 and the negative 7 to make negative 28. Combining these middle terms, and we get 6x to the 4th minus 13x squared minus 28. Continuing on. We now have a binomial times a trinomial. So the x in the first parentheses is going to begin to multiply by everything in the second parentheses, and then the negative 3 is going to get its turn to multiply by everything in the second parentheses. So we'll begin with the distribution by x. X times each thing on the right there gives us x to the 3rd plus 3x squared plus 9x. And then multiplying the negative 3 by each thing in the next parentheses gives us negative 3x squared minus 9x minus 27. When we add down, it turns out that a bunch of these terms cancel each other out, and our product here will be x cubed minus 27. Done. Problem number 7. 3 things in each parentheses. There is no shortcut. This just takes time. We begin by multiplying x squared times all 3 terms in the second parentheses. That gives us x to the 4th plus x to the 3rd minus 5x squared. We then take 4x times each thing in the right. 4x times x squared makes 4x cubed. Notice I lined it up underneath the other x cubed term. 4x in the middle times x in the middle makes plus 4x squared. And then 4x times the minus 5 to the far right makes minus 20x. At long last, we multiply the negative 2 by each term in the second parentheses, which gives us negative 2x squared minus 2x and plus 10. I've already got all the like terms lined up, so adding down to the x to the 4th column, we have x to the 4th. With the x cubes, we got 1 plus 4 making 5x to the 3rd. In the square column, we've got negative 5 plus 4 minus 2. That's negative 7 plus 4, negative 3x squared minus 22x, finally plus 10. And this last problem is kind of an interesting problem. It kind of gives you a visual way of multiplying things together. If we viewed these as 4 small rectangles, and we wanted to find the area of all 4 of these added together, I'm going to write that down, 4 small rectangles, rect. Basically, we're going to have the first rectangle, x times x, giving us x squared. To the right, we have it's x units tall, 5 units wide. Length times width gives us plus 5x. Down here in the bottom left, it's 3 units tall, x units wide. That's plus 3x. And the bottom right one here is 3 times 5 plus 15. Now, if we were to view this as one large rectangle, then the height is x plus 3 going along the sides, and across the top you have x plus 5. And so the comment we want to make here is how these two are both equal. Viewed in a different way, you have kind of a geometrical way of describing this area.